Hi dear all, so today we will talk about my project that I developed specifically for CS50. The project title is EmbryoPhaseSim, Radiated Percolation and Tissue Phase Transitions. When it comes to definitions, a phase transition is a sudden change in the collective state of a system when a control parameter like temperature, density, or connectivity crosses a critical threshold. The main states can be fluid-like, unjumped, floppy, solid-like, jumped, rigid, and critical, where a system is on the edge between order and disorder. This work was largely inspired by the seminal work of Petrudo and others published in Cell in 2021, and here we can see that there exist critical points that prompts tissues to choose their viscosity and go from high viscosity to low viscosity, as well as change their cell connectivity, that is, the number of cell-to-cell contacts. And the motivation was for this project to translate cutting-edge developmental biology findings into a computational model showing how tissues in embryos undergo phase transitions governed by cell connectivity rather than just cell density. By simulating a rigid percolation in embryonic tissue, the project makes abstract physics concepts like criticality and jamming accessible to students and highlights their role in morphogenesis and tissue mechanics. So this project will generate two outputs. First output will be a text output. First, it will prompt user to enter the number of contacts per cell. Then it will give connectivity, giant cluster size, predicted viscosity, and also the state of the tissue, that is rigid or floppy. And it will also add a general phase map with a critical threshold as red dashed line. So let's see how it works. If we enter the number of cell contact 6, we'll have connectivity 6, giant cluster size 0.86, predicted viscosity will be high. It will be 87.82, tissue phase will be rigid. But when we enter the number of contacts per cell 4, the connectivity will be 4, giant cluster size 0, predicted viscosity 10, and tissue will be floppy or fluidized, which is correct biologically. That is all for today. Thank you for your attention.